Now, if the base is something other than 10, the approach is essentially going to be same, except that we are going to use the base instead of 10. The way 10 showed up in the calculation was it was used to divide the number by 10. Now we will divide it with whatever new base we have. So let's try to decide the number that we have if I have base 8. So this is the same slide as the one before. Recall that this number was 125 in base 10. And now we are going to focus on writing this number in base 8. So I'm going to divide this in groups of 8. So if we do the math right, I will have 15 groups of 8 and 5 would be left over. That will be my least significant digit. Once again, the moral of the story so far is I'm going to divide the number by 8. Whatever is left, that's the least significant digit. If I want to find the next least significant digit, I'm going to represent the group of 8 O's by E, and I'm going to write the number E as these many E's plus O's, and discard the O's, group the rest in groups of 8, and that will give me that the next least significant digit is 7. Keep going. The next least significant digit is 1, and therefore the number is going to be 0, 0, 0, 0, as many zeros as I like, followed by 175 in base 8. So moral of the story is we start with the number divided by 8. The remainder is the least significant digit. We reset the number to be the quotient, and we repeat until we get the final answer. So let's focus on this example. We want to convert 6543 in base 10 to base 8. So in that case, we are going to divide by 8. The quotient will be 817. The remainder will be 7. Keep doing this, and the remainder will be like this. And we are going to read this number backward because this is the least significant digit, and that's going to be the most significant digit. So this is the algorithm to actually convert it to base b. So we divide n by b, let q be the quotient. We are going to take the quotient and the remainder, and when the quotient becomes 0, we are going to stop. This is how the algorithm would look in code form. Basically, I'm going to set the quotient to be n, and while the quotient is non-zero, we are going to find the digit by taking the mod operation, and we're going to find the new quotient by taking the floor operation of the division. Here is an example of converting 50 to base 2. We are going to divide each time by 2 and take the remainder. So in this case, the remainder is 0, 1, 0, and so on. And we read the number in this order. That's why the number will be 1, 1, 0, 0, 1, 0. Convert 26 to base 8, 18 to base 7. The answers are at the bottom of the slide. If they don't match with what you expect, then please check with us or recheck your computation. Converting from base 8 to base 10 is actually much more straightforward. Recall that the way we got place value system was we took this number 3 that had a weight of 10 to the power 0, 5 had a weight of 10 to the power 1, 4 had a weight of 10 to the power 2. Now if this was a number in base 8, then that would be 3 times 8 to the power 0 plus 5 times 8 to the power 1 plus 4 times 8 to the power 2. Note that all that I'm doing is I'm changing this 10 to this 8 because I'm changing the base to be 8. The rest is just figuring out what this number is, and in this case the number happens to be 299 in base 10. Check if you can do this, converting 56 in base 8 or 56 in base 7 to base 10.